Welcome everyone. In this lecture, we use a limit of a sequence. First, we will see what is the sequence, and welcome everyone. In this lecture, we will see what is the limit of a sequence. This is the outline of the lecture. First, we will see what is a sequence and which is not a sequence, and then we will see what is subsequence. And then we will see the definition of limit of a sequence and its geometrical interpretation and few theorems related to that. A sequence is a function from a natural number to a real number or a list of number that exhibits a particular pattern. A sequence is a function from a natural number to a function means what? It is a rule which assigns every element of domain to a unique element of a codomain. So the sequence of element of the sequence can be denoted as f of 1, f of 2, f of 3 because we know natural numbers are 1 to infinity. So the images, like we are writing the entries of a sequence, these called entries of sequence or element of sequence. A sequence can also be denoted as x and n equal to 1 to infinity. Like for sequence means what? There is some hidden rule is there to define a nth entry or the next entry, right? So here, what is the hidden rule? If 1 is there from the natural number, I'll put it to 1 by 1. 2 is there, then 1 by 2. 3 is there, then 1 by 3. So n is there, 1 by n. That is the rule. Putting n as a 1 by n, that is the rule of the sequence. Okay. Now, this is a constant sequence. It maps every element to the entry 1. Okay. Now, this is also another example of a sequence. Now, we'll see what is a subsequence. Subsequence is a sequence of elements of sequence only, but may not be all the elements. So subsequence, we can write it x of g of n equal to infinity. C is another function, means another rule is there. In such a way that only the restriction is the g of n should, range of g of n should be in a natural number, then only we can get it from the original sequence. So, and also g of n can be anything. So if my first entry in this subsequence can be 10th entry in the sequence. So whatever the function we defined here or subsequence definition, it will, according to it will obey. Okay. So from this, from the above thing, what like we can say some subsequence like 1, 1, 1. This is also subsequence of this sequence. Also 2, 2, 2, I will take, that is also subsequence of this sequence. Okay. And here from 1 by n to infinity if I take, that is also another subsequence. We'll see what is not a subsequence. What is not a sequence. First to know that we need to know what is the sequence, like what are all the things are there. As I said earlier, we know if I want to my nth entry, I know, or next entry, I know, because there is some rule is there. So I can tell what is the nth entry, right? And also it is infinitely many elements are there because the function from natural numbers and we are denoting all the elements as entry. So it is infinite. So any set which is only finite element, it's not a sequence, right? Also, like we can tell in the sequence, it is the first entry, it is the next, it is like third. that enumeration is possible in the sequence. But we know also, we also know the real set of all real number. We can, it is not a countable. We cannot say this is first entry or this is second entry. So that is also not a sequence. Now we'll see what is the limit of a sequence. A real number n is said to be the limit of a sequence an. If for every epsilon there is an n such that there is an n in natural number such that for all n greater than or equal to n, the distance between an and L should be less than epsilon, right? Okay, if it is satisfying this condition for every epsilon, there is a for every epsilon there is n satisfying this inequality. Then we call this L is a limit of a sequence an. Okay. So like how it is a limit, or in this case, if we carefully notice, for every epsilon we will get n, right? Such a way that they accept the finite numbers, their distance with L is less than epsilon, right? So if I take epsilon is as much as small, it's very close to 0. Still I can find n by the definition of this, still I can find n such that only finite entries are left. All other entries with the having distance with n is still lesser than that epsilon. This means what? They are very close in the sequence, except finite entry, all are very close to L. Then only distance are very less, right? So they are very close to L. So that's why it's saying it is if it is satisfying this inequality for every epsilon, we'll say these ANs are converging to L, or simply AN tends to L, or limits of AN is L. Okay, now we'll see in the geometrical way how it works. See, sequence I said is a function from natural number to R. So 1 means there is some A1 is there in that sequence. There is A2, there is A3, somewhere it is there. And what is the definition says? For every epsilon, I can find some n after n, all are in satisfying this inequality. This inequality means what? After nth entry, this an minus L modulus less than epsilon, right? This means another way saying is what? An belongs to L minus epsilon and L plus epsilon. So L minus epsilon and N plus epsilon, right? So that's what it says. So all my an somewhere here I forget to write an into somewhere here, and an plus 1, an plus 2, an dot all entries should be inside this. This is what it says. For any epsilon, I can find if my epsilon is here also, still I can find some n. It may be bigger than this, but I can find satisfying all these entries that belongs to this. Okay. See, it is true for all epsilon. However, epsilon small, still we can find n. So this means what? When epsilon going to smaller and smaller, their distances still should be less than epsilon, right? So those entries, it should be like very close to n. Like otherwise, it will not happen, right? That's why they are converging to n. If I take epsilon is very near, still I should able to find n. It may be too big, but still I am able to find n. After that nth entry, all elements are very close to n. That is the definition says. Then only I can say L is a limit point, right? So if it is happening, then we can say it is a limit point. Also, one more thing, if I exist one for one fixed epsilon, I get one n. Then after this n plus 1 also will satisfy this equation, because from n only all entries are inside this neighborhood. I'm saying from n plus 10th also inside this neighborhood. It's obvious, right? Because from n only all entries are inside this neighborhood. N plus 100, n plus 10 also it will be there. So if we know one entry, n, after that any n if we take, that also this inequality true. This just keep in mind, it will be helpful in some other places. Okay, now we'll give some example. 1 by n equal to 1 to infinity is converges to 0. And the sequences 1 to 1 to and sequence n does not converge to any real number n. We'll see how through the graph how it is happening. See, 1 by n sequence how a1 is 1, a2 is 1 by 2, a3 is 1 by 3, an is 1 by n. Like that it is there. So a1 is 1, a2 is 1 by 2, and all are positive numbers because n is a positive number. And they are decreasing. When n increasing, 1 by n is decreasing, and they are positive, and if n is closer to 0, okay, how we can get this? How we can say it is closer to 0? See, what is the definition of limit? An minus that limit should be less than epsilon, right? For all n greater than or equal to n. What is our an? Ans are 1 by n form. I'm saying 0 is the limit point. So if I take 0 here, what is this mod is? Because in 1 by n, right? Because already it is a positive number, no need to put. We need to tell 1 by n less than epsilon, right? That if we say this for every epsilon, we are done. 0 is the limit point of this sequence 1 by n. Okay. How will get that n? See, we know Archimedean property, which says for any x positive and real y real number, there will be some natural number such that x n greater than y. That is Archimedean property. So from that, if we choose y is 1, y is any number, so I'm choosing 1. Then epsilon positive is x I am taking. So epsilon n greater than 1. Right? For these two real number, I can get n by Archimedean property satisfying this inequality. So this means what? Epsilon greater than 1 by n. That's what we have to prove, right? 1 by n less than epsilon. So whichever the number n, it comes from the Archimedean property, will hold. Means after that, I need to choose in such a way that 1 by n epsilon. After the certain n, this will holds good. Okay. Now we'll see this example. What is this 1 2 1 2 sequence? Like in every odd entry, it is 1, and the every event position, it is 2. Okay, it is mapping like that. The sequence entries are like this. Okay. Now we are saying it is not converges to any real number. Okay. Any real number. The sequences converge means what? Their elements should be close to some L, right? We know these ones are here and here. Other than 1 and 2, if I take any real number, it will not be a limit. Why? See, if suppose you take here, and then we know from if I take here, distance between 2 and this point is smaller than the 1. So I am taking distance between these 2 and that point, whichever point I am choosing here as a real limit. And then making divided by 2 or 4. Then what will happen? The neighborhood will not intersect this one, will not intersect that line 2, right? So will not have any point of this and any point of this also. So that is not a limit point of this sequence. Same way, if I consider it here somewhere, I can find distance between that point to this one. And still epsilon I can take that distance divided by 2, 4 or whatever it can take. That neighborhood will not intersect any of these points. Means it will not contain any of the sequence points. That only it means, right? So after certain stage, it should contain all the sequence points. Then only we can say limit, right? So that also will not hold. Okay, what is the 1 and 2? Can it be a limit point? No. Again, the same logic. You know limit, the distance between 1 and 2 is 1. So take the distance is half or lesser than that. That neighborhood will not intersect these points because this distance is 1, but we are choosing the epsilon is very smaller than less than or 1 by 2 or 1 by 3, something like that. So in this neighborhood, it will not intersect the even entries. What is the definition says to say it is a limit point? Except finite, all should be inside this neighborhood, right? But here, there are infinitely many points, like all even points are outside this neighborhood. If I say 1 is a limit point, so that is wrong. The same way 2 also we can say this is also wrong. So 2 is also not a limit point. So no real number is a limit point of this sequence. Okay. Similarly, you can see for n also. Okay. Now we'll see a sequence diverges to infinity, or some will say it is converges to infinity. It's depending on the people. A sequence xn is diverges to infinity if for every n positive there is an n such that xn should be greater than or equal to n. Sorry, xn's are bigger than m for all n greater than or equal to n. But it says, like, however the big n, if you choose, still my xn's are bigger than that m, except finitely many xn's. That only it says, right? However big you choose m, still my xn's are bigger than that. So this means what? These xn's are converging to infinity. Means they are very close to infinity, because however big real number if we take, still these xn's are bigger than that. So that should be very close to infinity. That's what it means. If it is satisfying for every n, this one, then we can say it is diverges to infinity. Okay. The example is n sequence n equal to 1 to infinity. Similar way, the sequence diverges to minus infinity. For every m negative, there is n such that xn less than m for all n greater than or equal to m. Here also what they say is, however the small m you take, however the small real you take, still my xn's are lesser than that, except finally many points. So this means what? They are very close to minus infinity. If you say they like some like 10 power 100 or whatever, if it is poles, means sorry, means I think you are clear to that. It will not, if it is satisfying, these xn's will not close to any other number, because if it is closer to some other number, this will not valid, because that number if you take, m should be lesser than, these xn's are lesser than m, but m I can take smaller than that number, so xn's should diverges to minus infinity. Okay, so the example is minus n equal to 1 to infinity. If a sequence is not any of the above form, we say it is oscillatory, like it is not diverges to infinity or minus infinity or convergence. We can call it as a oscillatory 0, 1, 0, 2, 0, 3, 0, 4. All the even terms, we take 0, and then rest of the terms, you just take it as 1, 2, 3, etc. So this sequence is oscillatory because see what it is doing, 0 and then going to 1 and coming back to 0 and then going to 2 and then coming back to 0 and going back to 3. So it's like oscillating, right? So that's why we say it is a oscillatory sequences. Okay, this is also another example. Now you see, if a sequence xn converges to a limit L, then every subsequence converges and converges to the same L. How it is? See, every sequence and subsequence we know. Subsequence means elements of xn only in some particular way. it is written, what we say, Xn converges to L means what? After N, all are inside this neighborhood. L is uniform and all are inside the neighborhood, right? After N. I am taking some subsequence, not all these elements. Inside that, some few elements only I am taking. This because all these elements only inside this neighborhood. In that few I am taking, that also will be inside that neighborhood, right? This also is holds right for every epsilon because Xn converges to L means this is happening for every L, for every epsilon, this is happening. So after that nth term, all elements are inside this neighborhood. So in that, some few elements I'm missing, still those also will be inside this neighborhood. So that subsequence also converges to this L. I hope you understood. If any clarification needed, you can write it in the comment. Okay. Suppose a subsequent if sequence converges, every subsequent converges to the same means geometrically. Suppose what it will happen if subsequence converges? Can we say the original sequence converges? No, right? Because we already saw the example itself, 1 to 1 2 we have taken, and we can take from this the constant sequence as one subsequence, and then to another subsequences. We know constant sequence will converges to that constant number. Why? Because 1 minus 1 is what? 0. C minus E, whatever you consider. Like what do you need to say? I'm saying constant sequence converges to that number. If I take both are same, then it will be 0, right? 0 always less than positive epsilon, right? It is true from the first element itself. So always constant sequence converges to that constant element. So here also it converges to 1 and it converges to 2. So two subsequences. I'm saying one subsequent convergence, but still I'm unable to tell this is sequence because I have given the explanation why this 1, 2 is not a convergence, right? And converging to any points. So, like even if we know the two sequences, or like from this example or from this theorem itself, we can say what it says. If it is sequence converges, every subsequent converges to the same L. So if I am having two subsequences converging to two different limits, then directly I can say that original sequence will not converge. So from this theorem we can see, or even from this example also we can understand that. Okay. Now you see, like okay, when we said if subsequence two subsequence or some few subsequence, if we say convergence, still we are not able to say because we have the example. But when it will happen? When it will happen, if I am able to know about subsequence, when I can tell about the sequence convergence or not. When it will happen, if you are taking the subsequence as an all even term as a one sequence, and then all odd term as another subsequence, then and both are convergence to same L, then you can say the original sequence also converges to L. Why it is happening? Because see the same graph I will show you. Okay, first we will see this x2n plus 1, sorry, x2n converges to L. By the definition, for every epsilon there is an n1, because two things are there. I'm just writing n1 and n2. There is an n1 such that this x2n minus L less than epsilon for all n greater than or equal to n1. Same way, xn2 plus 1 also converges to L, right? So what I am saying, this is also convergence. So there will be some other n2, right? This is another sequence. There will be some another L2, n2 that is saying this inequality. Okay. Now, if I'm like already in the beginning, I told, if something is true, this inequality for some n1, it is true for bigger than this n1 also. That is what I told in the graph. And this is also true bigger than n2. So if I'm choosing n as a maximum of n1 and n2, this both inequality is true, right? So this means what? After this n, in the sequence, all terms also satisfying this inequality, even terms also satisfying this inequality. So simply I can write xn minus L is less than epsilon. And this is for a fixed epsilon, we got all this. So it is true for all epsilon. So we can say xn converges to L. Okay. Now, what is this example says? It is only valid if these two subsequences converges to same name. Because I can take some other subsequences converges, still the original sequence will not converge. That is the example I have given here. From here, you take this first entry, and then fifth entry, and then this entry, and then dot 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 all ones, like whatever the things are there right there. And then another sequence take this third entry, and then fourth and fifth and sixth. This is another sequence, another subsequence. So these both subsequence is a constant sequence, and they are converges to one. And they are converging to one, but the original sequence will not converge because it's going 1, 2, 3, 4, infinity. Those numbers also are coming inside that, so it will not converge to any point. Okay. And one more thing, if xn as a limit, it is unique. If xn has a limit, it is unique. Means it cannot converge to a 2 points. How? See, suppose you assume this is L1, this is L2. This xn converges to 2 point. And I know for every epsilon, there is a neighborhood and that neighborhood of L with L contains all of these xn points, right? Okay. Similar way, I told this L2 also limit point. So after the first sum n, all these xn's are inside this neighborhood. I can take bigger of these n1 and n2 as we did before. I'm telling the same entry, these ans are some ans or xn's, the fixed entry, fixed real number is two different neighborhood. How it is possible? It is not possible. It is possible only if they are same, right? So that's why the neighborhood is same only if these L1 and L2 are same. Okay. Now, if xn and yn are this we call it as a sandwich theorem for sequence or squeeze theorem. If xn and yn converge to same L, and then it is having xn, ans are in between xn and yn for all n, or for all after a certain finite n, because we want that limit convergence. What we need after the some finite stage, what is happening, that only matter. So even if we have this inequality after some 100th stage or after certain n, then also holds for all n also. This result is holds. Then the sequence an also converges and converges to the same L. Why it is? Because see, xn converges to L, yn also converges to L. This means what I'm saying, there will be the line where again from the graph only we can say there is a line L. These xn's are converging. This means what? xn plus 1 L entries are inside this neighborhood. Yn also converges to this L. So after some n2, all these yns are inside this, right? Okay. Xns are here, yns are here, yns are here. Take maximum also. So all x and yns are inside that some same neighborhood. And I know xn, an is bigger than xn and lesser than yn. So that also will be inside this neighborhood because bigger element also there, smaller elements also there. So in between number, that also inside this neighborhood. So this means that an also converges to L. So this is helpful if the sequence is kind of difficult. Like instead of seeing that sin n by n sequence, we can simply see for a minus 1 by n to 1 by n. We know sin n values are between minus 1 to 1. So minus 1 by n less than or equal to sin n by n and less than or equal to 1 by n. And we also know this is converges to 0 and this is also converges to 0. That you can, these are, we already see, this also you can check. So these both are converges to 0. In between sequence A and also converges to 0. Okay. Now the question is, there is a sequence I have written 1 minus 1, 1 by 2 minus 1 by 2, 1 by 3 minus 1 by 3. Like it's like 1 minus 1, 1 by 2 minus 1 by 2, 1 by 3 minus 1 by 3. Okay. This sequence also looks like oscillator, right? And it is also converges to 0. It's just a combination of minus 1 by n and 1 by n. So will you put it this in the definition of oscillatory or in this sequence in the for a collection of convergent sequence? Just think about this. And if any doubt is there, please ask in comment section. Thank you.